Welcome to our intermediate algebra class, and the challenge is very nice today because we are talking about pizzas, one of my favorite subjects. How many whole pizzas can you see in this picture? Look at the picture, and it's kind of hard to find out because the slices are all arranged in a weird way. Can you find out how many whole pizzas? How many whole pizzas? Not how many slices, how many whole pizzas can you see in the picture? Okay, check how you're gonna do it and write down your answer because today we will talk about rational expressions. We are entering chapter 6 and that's the reason of the challenge. This is all about fractions. Rational expressions means fractions. Section 6.1 about rational functions and multiplying, dividing rational expressions. When we talk about rational, you're going to remember the word ratio, right? Ratio. And that means quotient or fraction. We will talk a lot about fractions, but now fractions that have not only numbers, but since we were talking about rational expressions, we will have letters and numbers mixed with letters, some fun stuff like this or like that. And I'm pretty sure you are excited, right? Because you love fractions. Now it's much nicer because you have uh, variables and numbers on the numerator, variables and numbers on the denominator. Don't worry, don't be afraid. I know it's not the favorite topic of many students. The first thing you're gonna understand about fractions is how to find the domain. This is kind of something very simple, okay? And we're not gonna spend a lot of time on it. Basically, when you have a question asking you find the domain of a rational function, you're gonna look only at the denominator. Forget about the numerator, only look at the denominator. The denominator cannot be zero. Remember, if we have any number, let's say any number over zero, this is undefined. In a function, we cannot have undefined. We need to have each input with one output. So we cannot have zero on the denominator. Letter A. What is the value of x that makes this denominator equals to zero? Think a bit before answering. Of course, this denominator will never be zero. That means the domain is going to be all, let me write now, domain, that means x, right? X can be any number. So domain is all real numbers. There's no problem, there's no value of x that makes 3. 3 is always 3. It's never going to be 0. What about x minus 1? What's the value of x that makes x minus 1 equals to 0? Think x minus 1 equals 0 plus 1 on both sides. We have x equals 1. We cannot have x equals 1 in this function, or we will have the denominator equals to 0. That means the domain is going to be all real numbers, but x different from 1. All real numbers, but we're going to exclude 1. 1 cannot be domain in the domain because we'll make the denominator equals to 0. Now the last one. The last one is a bit trickier because we have x squared minus 2x minus 15, right? And you're going to remember that quadratic equations, they have two solutions usually. what are the numbers that will make this denominator equals to 0? So write down x squared minus 2x minus 15 equals 0. Let's find those two numbers. We can use, on the last section, we talked about the guessing methods, that you can guess two values that multiplied is equals to, in this case, 15, negative 15, and if you add these two values, you have negative 2. So think about two numbers that multiplied is equals to 15, and we can think about 1 times 15. We can think about 2 times something. No, not 2 times something. Maybe 3 times 5. And I think that's it. Well, to make negative 2, we can have negative 5 and 3. Because negative 5 plus 3 is negative 2. Negative 5 times 3 is negative 15. Perfect. This is the guessing methods. We guessed these two values, x minus 5, x plus 3, and what makes this expression equals to 0? This multiplication of two binomials, of course, the domain. We cannot have x equals to negative 3, or we cannot have x equals to 5. So all real numbers, but we will exclude negative 3 and we will exclude 5. Okay, so that's it about domain. This is just a small thing, a small detail about the rational functions. The next topic is about simplifying rational expressions. And now you can make some kind of a mark here, like a star, an asterisk, right? Because this is going to be very important throughout all chapter 6 and even later, because if you remember, every time you find a fraction as the answer to a question, let's say you calculated and you found x equals 12 over 8 as an example. You cannot leave it like that. You have to simplify this fraction, because 12 over 8, we can divide both by 4 and we have 3 over 2, right? Always simplify. And that works as well if you have rational expressions with letters and numbers. Look, this kind of looks like hard to simplify. Of course, if you have, in the last example, 12 over 8, you can break down 2 times 2 times 3, 2 times 2 times 2, and cancel, 3 over 2. Actually, this is pretty much what we're going to do. We will factor out the expressions using some knowledge from the last section that we covered, the section 5.7. And in this case, look at each one, the numerator and denominator. I think we can use that guessing method. Remember? Look here on the top, we have 3, we have negative 4. Think about two numbers that multiplied is equals to negative 4, and if you add is equals to 3. Again, make a list, 1 times 4, 2 times 2, and that's it. The only two numbers that combined, we can have negative 4 as a multiplication and positive 3 as the sum, will be 1 and 4, right? Because negative 1 times 4 is negative 4, negative 1 plus 3 plus 4, sorry, is positive 3. And we can write as x minus 1 times x plus 4. Great. On the denominator, now think about two numbers that multiplied is equals to negative 20, and if you add is negative 1. Making a list, 2 times 10 is 20, 4 times 5 is 20, what else? That's it. Well, I can see that 4 times 5 we can combine, and Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. Okay, we can write down x minus 5. Oops, is minus. Let me move this dot. Okay, and x plus 4. Great, excellent. If you look, I'm erasing here my scratch. This is just some scratch calculations. See, we have a common factor that is common on the numerator, on the denominator, and if we divide a factor that's the same, x plus 4 divided by x plus 4 equals to 1. So we can just cancel out. And the simplest form of this is x minus 1 over x minus 5. That is our final answer. See, it's not so hard. We just have to use some methods that we covered last section 5.7. And look at this expression now and think, because it looks tricky. How can we simplify the following expression and make kind of also an asterisk like the star, because we need to factor out, but there's not much to factor out. Just one tiny thing that we can factor out here, the negative 1. We can factor out negative 1 either on the top or on the bottom, because 7 minus y is equals, factoring out negative 1 times negative 7 plus y, right? Okay. And negative 7 plus y is the same thing as, you can change the order, it doesn't change at all, y minus 7. So write down here, negative 1, y minus 7, on the bottom, y minus 7. And we have the same factor on the top, on the bottom, and the answer is only negative 1. Negative 1 is the final answer. Okay. See, we just factored out the negative 1. Look what we have now, x3 plus 8 divided by x plus 2. Remember last section 5.7, right? And on the top we have the sum of two cubes, x cubed plus 2 cubed. On the top, on the bottom, x plus 2. And we will use the formula. Let me write down here on the bottom the formula from section 5.7. A3 plus B3 equals A plus B times A squared minus AB plus B squared. That's the formula we're going to use to simplify. So this is equals. A is x, B is 2. So x plus 2 times x squared minus AB is 2 times x, so x times 2, plus b squared, 2 times 2, 4, over x plus 2. And now we have the same factor x plus 2 and x plus 2 to cancel out. The simplest expression that results from x cubed plus 8 over x plus 2 is x squared minus 2x plus 4. That's going to be the final answer. All right, next. And we're getting more and more kind of, it looks hard, right? The examples, they look hard and they look harder. But let's try. Let's try using all the tools that we have. First, look at the numerator. 2y squared plus 2. I think we can find a greatest common factor between these two terms. Can you see the greatest common factor? Yes, 2 times y squared plus 1. On the bottom, we will have 1, 2, 3, 4 terms. And those 4 terms, I don't remember any method from the last section that we have 4 terms like that. We will try to split and we will work with y3 minus 5y squared. We will try to find some kind of greatest common factor among them. And let's write down the plus here. Plus. And the other one is y minus 5. We're going to use a method that's called factoring by grouping. We will factor out this group. Separately, we're going to factor out this group. And we'll see what happens. Y squared plus 1. Looking at this first group, I can easily see that we can factor out y squared. So y minus 5. On the second group, we don't have anything to factor out. Actually, when we don't have any greatest common factor, actually the greatest common factor is 1. 1 y minus 5. Now look, we created a common factor, y minus 5, that we can factor out. And then we will combine y squared plus 1. Look, now we have this chance to factor out y minus 5. And then we have y squared plus 1 on the bottom. And on the top, we have 2 times y squared plus 1, which is very good, since we can cancel y squared plus 1, y squared plus 1. And now we have 2 over y minus 5, which is the simplest form of this rational expression and will be the final answer. Okay, this one was hard, but we managed to work it out. Now, we can work out, and you're going to remember how to do this with numbers, multiplication of rational expressions. It's basically the same thing you do with numbers. If you have this fraction, 2 over 3, you want to multiply with the fraction, let's say 5 over 7. You will multiply across. That means multiply the numerators, 2 times 5, 10, and multiply the denominators, 3 times 7, 21. This is how you work multiplication of fractions. The same thing is working with rational expressions. You multiply the top, the numerator, you multiply the denominator, and you find the answer. In this case, this example, multiply the following rational expressions. So draw here the fraction bar, and we have m minus n squared times m times m. Let's write with the parentheses just to make it real clear what you're doing. And on the bottom, m plus n times m squared minus mn. Okay, the multiplication is actually simple, easy, the same thing we do with numbers, but now comes the tricky part, is finding out how to simplify. We need to give the simplest answer. Look on the top, this is already factored out. This is, we cannot factor out anymore. This is also in the simplest factor, but this expression here we can factor out a little bit because we have m squared, we have m. We can move m. M is going to be a greatest common factor between these two terms, right? So we can write, keep everything else the same. Everything else will be the same. M plus n. And we can factor out the variable m. M times m is squared. No, it's not square anymore because we factored out m minus n. Now check what can you cancel out with the factors that are the same on the top and the bottom. Of course, m is the same. Anything else? Yes, we have m minus n. We have m minus n. Just remember, I'm going to write down, but maybe you're going to remember this. I don't actually need to explain. M minus n is square is the same thing as m minus n times m minus n, right? And if you have m plus n, m minus n, we can cancel out one m minus n with another m minus n. And the last step, that's the final answer. The simplest expression is m minus n over m plus n. That's going to be the final answer. Okay. Next is division of rational expressions. Again, remember what you do with fractions, with numbers. 2 over 3. Let's say you want to divide by, let's think here, a number 6 over, no, let's make this 5 over 6. And what are you going to do if you have numbers? Yes, remember, this is a way of remembering. Keep, change, flip. This is not official math, but is a way of remembering what to do. Keep the first fraction, change the operation into multiplication, and flip the second fraction. Flipping means you're going to write down here the reciprocal. And now you just multiply. Multiply 2 times 6, multiply 3 times 5. The answer is 2 times 6, 12. 3 times 5, 15. Easy if you remember to keep, change, flip. But still, this is not the final answer. You need to simplify, right? You can divide by 3. You can divide by 3, both numerator and denominator. And the final answer actually is 4 over 5. That is the final answer. So again, division is not hard. Sometimes the simplification is tricky. Look, let's try this one. Divide parentheses x plus 3, close the parentheses, squared over 5, divided by 5x plus 15 over 25. Perfect. Remembering keep, change, flip. Keep x plus 3 squared over 5. Change the operation to multiplication and flip or reciprocal of the second one. Find the reciprocal of 25 over 5x plus 15. Nice. Multiply across, and then you have x plus 3 squared times 25 over 5 times 5x plus 15. Again, this is the answer, but not the final answer. We need to simplify. And, and I can quickly see something that we can simplify. 25 divided by 5 is 5, right? So we can simplify this. Anything else? Look closely each one of the expressions. Yeah, this is factor out. And this expression, we can factor out something on this expression. I think it's possible to identify that we can factor out 5. 5 times x plus 3. See, 5 times x, 5x. 5 plus times 3, 15. On the top we have x plus 3 squared times 5. And more simplifications, because 5 divided by 5 is 1, and x plus 3 squared divided by x plus 3 is just x plus 3. Remember the last example, right? We can write down x plus 3 squared as x plus 3 times x plus 3. That's the final answer. See, much simpler than the original expression. Much, much simpler. Look, this is a hard, very difficult question. I will not be able to show all. I think we're going to need only one video exclusively for this expression, but I will show at least one of this, one of the factoring out that you can work here. Look, this is 18y squared plus 9y minus 2. Each one of the numerators and denominators, we need to factor out to be able to simplify. Okay, but the first thing we are able to do is change the division into a multiplication. So you can write 18y squared plus 9y minus 2 over 24y squared minus 10y plus 1 times change to multiplication and flip 8y squared plus 18y minus 5. Okay, and just remembering, flipping is not the technical or the official name of this that we're doing. We are finding the reciprocal. Yeah, it's flipping. Okay. Now for each one, let's get just one example. Let's say this looks simpler. 3y squared plus 17y plus 10. We will need to factor out each one. And we have to use factoring by grouping is another technique. And you will multiply 3 times 10, 30, and 17. Find two numbers that multiplied is equals to 30. If you add is 17. And I can easily see that we will have 2 and 15, right? 2 times 15, 30. 2 plus 15, 17. Cool? All right. Just erase this. We're going to need some space. Write down 3y squared. Only this one. Only this denominator. 3y squared plus 15y plus 2y plus 10. And remember the factoring by grouping we did before. When we have 4 terms, we split it 17y as 15y plus 2y. Now you have 4 terms. Factor out here on the first couple of terms 3y times y plus 5. Factor out on the second term the 2, y plus 5. And finally, we can factor y plus 5 on both, right? We have y plus 5 here, y plus 5, so factor out y plus 5. Great. Now, if we come to this expression, you can replace by y plus 5 times 3y plus 2. And you're going to do the same thing for this, and this, and this. Okay, the same operation. This example is kind of hard and long, but let me show the whole thing, how it looks like. See? You do the keep change flip, you factor out each one of the numerators and denominators, you find all the factors that are common on the top and on the bottom to cancel out, and the final answer is 2 times y plus 5 over y plus 5. That's the final answer. But this is just one situation, one example. Not all questions will be as hard as this one. You can also have, as on the next example, a combination of multiplication and division. You just have to work 2 by 2. You work the multiplication, x squared minus 25 times 3x plus 15 over x plus 5 squared times 4x. And next, we work the division. And the division, we can use keep change flip, change into a multiplication, and flip or find the reciprocal of x squared minus 3x minus 10 over x. This is the reciprocal. Now multiply across as a simple multiplication, and you have the answer, which is not the final answer. It's not the final answer. We need to simplify yet. So a big fraction bar. So multiplied by x plus 5 squared, 4x, x squared minus 3x minus 10. Yes, we have everything. Look, another kind of long problem to calculate, to simplify. This is the answer, but not the final answer. Working out the multiplication division is simple, but not the whole work. The hard work is simplifying. We will need to check each one. Look, this is the difference of two squares. Difference of two squares we can represent as x plus 5 times x minus 5. Remember section 5.7, right? This one we have a greatest common factor, 3. So I'm going to use different colors for each one. 3 times x plus 5. And we also have x on the denominator. X plus 5 squared is already factored out. We have 4x, nothing to do here. And x squared minus 3x minus 10. Think about two numbers that multiplied is equals to negative 10. If you add is equals to negative 3. And you're going to come up with x minus 5 and x plus 2. Negative 5 plus 2, negative 3. Negative 5 times 2, negative 10. Perfect. And finally, cancel. Cancel x plus 5. We can cancel if this is square. The x, you cancel if the x minus 5, if x minus 5. And I think, oh, we have x plus 5 here, with the remaining x plus 5 here in the bottom. What else, what else, what else? I think that's all. And the final answer will be 3 over, that's what remains on the numerator, 3. What remains on the denominator? We have the 4 and the x plus 2. 4 times x plus 2. That's the final answer. Another example, kind of long, but yes, we have to do it taking our time, step by step. Okay. Last objective, using rational functions in applications. Very simple. We're gonna love this example because it's not as hard as the previous one. Look, for the ICL production company, the rational function Cx equals 2.6x plus 10,000 over x describes the company's cost per disk of pressing X compact discs. Find the cost per disk for pressing 100 compact discs and 1,000 compact discs. Well, this is a word problem that we will apply our knowledge about rational functions to solve it. And basically it's very simple. X is the number of compact discs. You have to find the cost if X equals 100 on letter A. And basically you just have to plug in. This is the function, right? So plug in X equals 100. 2.6 times 100 plus 10,000 over 100. Bring your calculator. On your calculator, you type 2.6 times 100 plus 10,000 equals, okay, divided by 100. 102.6. This is costs, right? So it's going to be dollars. $102.60. If we want to find letter B, it's basically the same thing, but now X equals 1,000. And then plug in C of 1,000 equals 2.6 times 1,000 plus 10,000 over 1,000. And now the cost, you need the calculator again, 2.6 times 1,000 plus 10,000 equals divided by 1,000. 12.6. $12.60. And this makes sense because usually when you have production, if you produce a least amount, the cost for each disk will be more. If you produce a bigger amount, the cost per disk will be less. All right, that's all. The next example is pretty similar. You can do by yourselves. Okay, if the company's cost per book for printing X particular books is given by the rational function C of X equals 0.8x plus 5,000 over X. Find the cost per book for printing 100 books, 1,000 books. You will use the same method to solve. What about our challenge? How many whole pizzas can you see in the picture? There are a few ways, a few methods. You can count the number of slices, right? You can count all the slices. If I'm not wrong, you're going to find 40 slices, and each each pizza has 8 slices, so you divide, you're gonna find the number of pizzas, or you can rearrange the slices and complete the whole pizzas. If you rearrange, oops, no, you rearrange this, and you can rearrange this too in the middle, and you're gonna have 1, 2, 3, 4, 5 pizzas in total. Another way is to use fractions. If you love fractions, this is 3/4 of a pizza. You have 1, 2, 3, 4 3/4, 4 3/4 plus 1, 2, 3, 4, 4 halves, and then you also will be finding the number 5 as your final answer. Thank you for watching, and hope to see you on the next section.